Great. Hey, Sudarshan, thanks for joining our podcast. Yeah, over the last few weeks, it's been super cool to try out some of your new voice models and voice agents. I know you run like a team of about 30 people right now. So just wanted to take a few minutes to first kind of understand how you run an engineering team and sales and everything that comes along with startup. If you can give a few words about what Smallest.AI does too, that'd be great.
Well, thank you so much, Aishwarya, for having me. Yes, we have a pretty large team at Smallest AI. What we do is we build foundational voice AI models and agents for large enterprises. So, mostly banks and financial institutions are our customers and other Fortune 500s. And we help automate very complex use cases such as customer support, sales, marketing, things like that. Anything that involves a human on a phone call. Managing a large team is like really tough. Um, as a small team, you can kind of go and talk to every single engineer. As you grow, it becomes very, very difficult. And so we have obviously been sort of tinkering around with many solutions to it. We love intelligence. We've been using it recently, and then that has definitely been useful. And yeah, happy to sort of go deeper, answer any questions about it.
Perfect. Yeah, I think one question is like a lot of people either work on the application layer or they work on like the agent layer, or not many people work on the model layer. So just curious how what you've kind of done to achieve kind of working on a few different parts of the stack in parallel. Also, kind of tangentially to that, how have you seen kind of AI coding tools ability to help at each of those? Like, is it more useful on full stack code or agent code, or are you also seeing it as helpful in kind of helping you develop and improve these
Yeah,
models?
that's a good question. So we started off at the model layer. We were initially a model only company. And very quickly, we realized, as everyone is realizing, that the application and the use case is what matters. And so we very quickly graduated into an application layer company, which meant that we were building text to speech, speech to text. So we have one of the world's fastest text to speech models called Lightning. We went from doing Lightning TTS to now having the whole voice agent. But the way we differentiate ourselves is when we go to deploy for a customer use case and the customer realizes there is a voice that they don't like, or there is, let's say, the transcript that is not coming correctly, or maybe the conversation intelligence is not great. We are actually able to fine tune these models to take care of the customer requirements. So this is an advantage that we have that our competitors don't. And so we essentially provide guarantees to our customers that it's gonna work versus other companies that might be relying on three, four different model providers. So managing both layers has been an eventual evolution of our journey. We have found a quality advantage, we have found a cost advantage to doing this, but obviously it comes at a cost of maintaining multiple teams with multiple specializations, right? And with respect to AI coding tools, I think it is really helpful for the application layer and for the inference on the model layer. But it is not that useful, at least not yet, on the dataset creation, training, evaluation phase, primarily because these things are evolving so rapidly that it's a research area in itself. We know companies that are trying to do um, AI engineer. So, like an AI engineer built by AI. But I think this is a very, very new thing. However, AI tech lead or AI sort of, just helping us do a lot of engineering reviews and security cleanups and, making sure the code is really well structured and working and optimized. That is something we have found success in application and influence.
Got it. Makes sense. So I was just curious, like over the time as you've adopted AI engineering tools in your workflow, right? Have you seen that any of your team practices have changed around, again, kind of what you mentioned for planning, for kind of building features? How do you kind of run different engineering groups or teams differently? How does that affect what you do with code review, security, etc.?
I think the first level started with just engineers using AI to complete code. That was like the first level of adoption. Eventually, this found so much success that a lot of code was being written by AI. And so we had, I don't know, like 50, 80% of the code being written by AI, with the 20% being the engineering supervision and last mile fine tuning that the engineering would add. And then what started happening was a lot of this had oversights because the AI doesn't have full context. The engineer sometimes is lazy to provide full context, or some of these tools cannot understand or ingest those full. the context, right? And so the AI would write code which is theoretically maybe correct for that localized use case, but then for our application, it does not work and it actually causes very serious production issues. We had engineering management tools that run with AI. We started, exploring a variety of them. We ended at Intelligence, but the idea was that there is so much AI-driven code. How can we actually measure what works, what doesn't work, and proactively point that out to engineers that they are making similar mistakes when they are writing code? So today, we start with using AI in engineering management as team leads or as with me or my CTO. We use it for PR reviews primarily. So reviewing PRs is you get like a good first understanding of what this code contains of and what are the issues, regardless of whether it's completely written by AI or human. It always helps to do a second round of pass. And then the other thing is getting like a global overview of which engineers are performing well and which engineers are not. So I think this is helping us like on a broader level. I think a lot of it is still maturing. We are still figuring out, can we, for example, automate bugs or can we do, security, things like that. Obviously, I think there is a lot of potential. And so, we are constantly on the lookout for things, but I think PR reviews and broader understanding of engineering velocity and engineering quality is something we have been able to get a very good signal on, automate to a certain level using AI.
Got it. Do you feel like your engineers are the ones who are championing and supporting this, or do you think as kind of the founders or yours kind of sharing or asking them to do this more? And where do you think that threshold is right now?
I think engineers obviously would like the AI PR review because even they get a quick review of their own code. And otherwise, it's like you're doing peer reviews and then you're going to a team lead, which takes up a lot of bandwidth, right? So PR reviews is a no-brainer, which the engineers champion. The other things like quality of like engineers or like velocity of engineers, etc., that is something that the team lead generally cares about a lot more than the actual individual engineers. They care more about their day-to-day tasks. But things like finding security vulnerabilities in existing code or like auto fixing issues that were found out through production logs. These are some interesting areas which engineers are exploring tools in. But I think generally speaking, any sort of broader level metrics goes to the team lead.
Do you think that there's a different set of tools that the kind of people who are working more on the model layer use versus engineers on your team, or is it pretty much equal in terms of value add and usage and all of those metrics?
No, I think it's drastically different. So the reason is the people who work on the model layers, 80% to 90% of their work is on data and evaluation. So we are talking about tools that can ingest a lot of data, filter it, clean it, analyze it, visualize it, and then maintain versions of data, and then ingest data into the training pipeline. So there is like all of the data processing, and then there is data ingestion, evaluation, which involves experiment logging and experiment metrics and things like that. But the concept of data sets and experiments and versions of it does not exist at all in application layer. And so the tools that are used by those engineers are different. Having said that, building this pipeline of the data set versioning, the data processing, etc., building the pipeline for evaluation, code that is being written for that uses similar PR review tools, for example. But I would definitely say that the data model layer probably is a slightly different set. I wouldn't say a superset, but like slightly, a different set compared to the application layer.
Got it. Makes sense. What do you think are some things that make your engineering team stand out? I know that you have consistently kind of been at the top of our leaderboard. What do you think you guys do really well, and what's kind of worked over the last year, year and a half to keep your team running really smoothly, even if, you're here, your team's in India or things like that?
Yeah, I think one thing that really helps is we have a very, very open culture and high ownership, high agency engineers. There is no concept of I'm just gonna ship this part of the code and I don't care if it goes and merges into the production and something else breaks. If you're shipping something, it's your responsibility to make sure production also works and the customer facing use cases don't break. And we hold our engineers to very, very high standards. Obviously, a lot of tools, the PR automation that you do through intelligence, the security reviews that you do, the issue production issues that you flag, all of these things actually help us help these individual engineers do a lot more than they otherwise would have. But having said that, the expectation from every engineer is very high, which they are able to meet because of tools that you provide. Apart from that, one thing we have proactively started doing is we get various engineers to start owning pieces of code. So this code has a owner who will be contacted for if there is even a single line of change in that part of the code, which did not used to be the case. Everyone would kind of change things based on their understanding, and things would start breaking. So that ownership process has started streamlining things when 10 people are committing to the same code repository. And that has helped us ship a lot faster.
Is that something you formalize? Like you have a doc or you have a kind of general agreement on everyone? What happens if there's like five features that touch one part of the code? Is that all delegated to one engineer, or how do you do it?
Yeah. If there are five features, so today most, I mean, while we are not a very big team, even I mean compared to let's say an Amazon or like a typical Series BC startup, but so I would say we are a decently lean team for our size and the amount of things we do. And having said that, so we only have one sort of point of contact for a part of the code. And so if there are five changes to that part of the code, it has to be signed off by that engineer or the team lead before, otherwise it will not go to production. That and also we focus a lot on tests. So we have started extensively writing tests for our platform. We use AI to write most of our tests, but there is still, because we are a multimodal in nature, a lot of our tests are also being discovered that there is no good way of testing multimodality. Another thing that has kind of helped streamline a lot of these things.
Or by tests, are you saying like data quality, model quality tests, or is this just general application?
For the model layer, model quality tests and data quality tests happen. Data quality tests happen during training, model quality tests happen after training. But for the application layer, you're talking about things like, let's say there's a call. Now you have to understand whether there was latency during the call. To understand latency, so this is actually a WebSocket connection that gets formed, and there are three to four different services that are sending or receiving data into that WebSocket. And so how do you know that the user stopped speaking at this point of time and your agent answered at this point of time? That has to be really accurate. And if there is a latency increase, you have to scale up your services. So you have Kubernetes that is tied on to some certain very, very custom metrics on that. And you have logs that get generated if the latencies go high. So it is very complicated. And this is just, we are just talking about latencies here. What about things like, for example, quality of the call itself? What if the agent hallucinates in production? How do you test for that? So there are anti-agents that come and call these agents to make sure, like, you have taken care of multiple use cases. And so there is a very large testing suite when it comes to generative AI. There is an even larger testing suites when it comes to generative AI on multimodality. And so this is on top of your basic engineering tests that your function is performing the way it's supposed to perform.
Wait, so if I understood right, you're literally testing your voice agents with other voice agents?
Yeah.
How's that been working out?
So if you think about it, it's kind of easier to build the anti-agent because the anti-agent can be very, very random. The only thing is like you have to make sure over a large set of tests, you are covering multiple use cases, multiple pathways so that you have kind of understood where it fails, where it succeeds, and you're not all concentrating to similar types of tests, right? So you could use, let's say, you could build a angry customer asking for a refund as a profile and make it call the customer support agent. But the angry customer, you could give the model a lot of freedom as to what it wants to speak, versus the customer support agent has to be heavily guardrailed and things like that, right? So it's actually easier to build anti-agents. The only complexity there is to maintain diversity so that across calls you are testing for various scenarios.
Is anti-agent a actual term? or did you
I
just create it?
I came up with it. I mean, not now, but like I've been speaking about this many times. We also work with some external companies that do this for a living. But I think so far we've seen that the space is also evolving. So we have our own agents, plus we have these external companies and all that. So it's a very long and complex process. We actually have a delivery team that only works on building demos and agents for customers. And so this team has its own testing, and that's where the anti-agent and all of those things come from.
Got it. Very cool. If you had to come up, tell me just like today, what is the kind of, even with all of these processes and tools and so forth that you have in place, what continues to be probably the most painful or annoying part of running your engineering team?
I think figuring out like from product requirements, like we are talking about front end, to actually if the code being written is performing what was expected. So design and product to actual expectation is not something AI has cracked yet. So AI is able to sort of say, hey, the code fine, the code performs as it's supposed to, but like, and we could run tests on the functions, but like it's not at a product level telling me things are doing. So if that was possible, then probably I will have 10x lesser engineers, right? Like to do things. I'll just give a PRD, the AI will do the whole thing, and the engineers will just review if the product works. If the product fails, the engineers will say, hey, this has failed in these cases. Can you fix it? I don't think it's ready yet. A lot of people claim to be ready, but I think the process is, yeah, it's far away from production. The other place which takes a lot of our time is building AI agents themselves, because our platform is a platform where you can build voice agents. So building those agents is, building a POC is easy. Production agent is really complex, takes a lot of testing, takes a lot of fine tuning to get that right. And so we are working on ways in which AI can build 90 to 95% of these agents, test for the last 5%. The delivery guy just has to sign off. Versus today, the delivery guy spends a day or so trying to build the agent, test the agent, and things like that. These are like two active areas of challenges for us. And I am not even going into the model level challenges because that's a big thing in itself.
Got it. Makes sense. Okay. Anything else you want to share about engineering at Smallest and why people should join your team?
I think we are a young, hungry team. We are very humble. We are high agency. We really don't care where you come from. We don't care what's your background. We have people who are some of the smartest engineers from the smartest, best colleges in the world. We have college dropouts. They're both in the same team, performing at similar levels. Sometimes I would say the dropouts are smarter. And so we just focus on shipping great code that is best in the world. And so if you are looking to do something interesting, something exciting in multimodality, the space interests you, and you think you have what it takes, hit us up.
Awesome. Okay. Well, I think that's it. Thanks so much for joining our podcast.